In my previous video, we looked at the problem of solving a system of equations using the method of substitution. Now, what I want to do in this video is look at an alternate method that could be used to solve any of the same problems. And in this case, the method I'm using is called elimination. Now, the first thing I want to do, or the first thing I want to say about the substitution method versus the elimination method is they both always work 100% of the time. There's never a situation where you have to use substitution where elimination won't work, or vice versa. So this is just an alternate method, and what you could do is you could decide for yourself which method you prefer and always use that one. Personally, I like the elimination method, but that's just me. So why is it called elimination? Well, let's look at this first system of equations. Now, this is, as with the last video where the first problem was set up very nicely, this one is also set up very nicely for elimination. Now, the elimination method says that you want to combine the two equations together. So add the left side to the left side and add the right side to the right side in such a way that one of your variables will be eliminated or cancel out. So let's look at problem A, and what happens if we add these two equations together? Well, we could combine like terms. So a negative x and a 9x will give us a positive 8x. And the negative 4y plus the 4y, well, those cancel. They're equal and opposite. So they give you 0. So we have 8x plus 0, or just 8x. And then we could take 17 plus 7, and that will give us 24. So we have the equation 8x equals 24. We can divide both sides by 8. So the times 8 to divide by 8, they cancel, and we get x is equal to 3. And we know that the answer is going to be an ordered pair, and we now know that the x value is equal to 3. And just like with the substitution method, once you have half of your answer, now you could plug that number back into one of the previous equations to solve for y. So if we take that first equation, which is negative x minus 4y equals 17. You could just as easily use the second equation. It doesn't matter. Well, now we know that x is equal to 3. So we could replace that x with a 3. So negative 3 minus 4y is equal to 17. Okay, so we know x is equal to 3. And now we want to solve for y. So we could add 3 to both sides of the equation. Those 3's will cancel, so we have negative 4y is equal to 17 plus 3, which is 20. And we could divide by negative 4. And we want to solve for y, so divide by negative 4, so the times negative 4, divide by negative 4, they cancel. And we get y is equal to negative 5. And that's the other half of our answer. So this is just a different method, or a different way of solving the system of equations. Now, like I said, this problem was set up very nicely. One equation had a negative 4y, one equation had a positive 4y. Usually that's not going to be the case. So let's look at another problem, number 2. Now, if we were to add these two equations together, well, it wouldn't be very helpful because the x's would remain. A 2x and a minus 4x would be a negative 2x. A 12y and a 7y would be 19y, and 12 plus 7 is 19. So all that did was, 19y, all that did was give us a third equation, which we don't want. So let me erase this, because the whole point of adding the two equations together is so that one of the variables is eliminated, hence the name elimination method. So with the elimination method, what you do is you multiply either one or both of the equations by whatever number you need so that you can make one of the variables equal and opposite. And remember, you're allowed to multiply an equation by anything you want, as long as you multiply both sides by the same number. So look at the x's here. We have a 2x in the first equation and a negative 4x in the second equation. Well, we could easily, so if we focus in on this 2x, we could easily make that a 4x by multiplying the first equation by 2. Then if we multiply the first equation by 2, then that first equation, if we multiply everything on both sides by 2, that first equation becomes 4x plus 24y equals 24. So we've just made a slight change or a manipulation to the first equation, and the second equation is fine the way it is. Negative 4x plus 7y is equal to 7. So now we have what we want. Equal and opposite. Positive 4x and a negative 4x, when you add them together, they cancel out and give you 0x, or just 0. So when we add these two equations together, 24 and 7 is 31y is equal to 31. We can divide both sides by 31. And we have y is equal to 1. Okay, so that's half our answer. Now that we know y is equal to 1, we could take that 1 and plug it into any of the other equations to solve for x. So I'll just take that first equation. It doesn't matter which one. If we know that 2x plus 12y is equal to 12, the original equation, we could replace y with the number 1. So 2x plus 12 times 1 is equal to 12. So plugging in 1 for y, or 2x plus 12 is equal to 12. And we're solving for x. Right? So we can subtract 12 from both sides of this equation. So we'll have 2x is equal to 0. If we divide both sides by 2, we get x is equal to 0. And that's the other half of our answer. Okay, so sometimes, occasionally, the system is set up for elimination and you just have to add them together because one of the variables is already equal and opposite, like it was in problem A. In problem B, we had to adjust one of the equations. If we made that positive 2x into a positive 4x. So then we had equal and opposite. But sometimes that's not possible either. And the third and final problem I want to do in this video, problem C. Well, we can't multiply one of the equations by a number, or at least by a whole number, to make it equal, to make one of the variables equal and opposite. But that's fine because we can multiply both equations. Now let me actually copy the problem twice. 3x minus 6y equals 12. 5x plus 4y equals 27. Okay, so it's the same exact problem twice. I'm doing this to show that the elimination method could be applied to either variable. It doesn't matter which one. So in the one on the left, if we focus in on the x's, we have a 3x and a 5x. We want to make the terms containing the x equal and opposite in sign. Now we could look at the smallest number or the least common multiple of 3 and 5. We can make that 3 into a 15 pretty easily. We can make that 5 into a 15 also pretty easily. So if we take the first equation and multiply by 5 to both sides, then that 3x will become a 15x. And then we'll have a minus 30y is equal to 60. 6 times 5 is 30. 12 times 5 is 60. And if we multiply that second equation, well, if we multiply by 3, that will give us also 15x, but they'll both be positive, so let's multiply by a negative 3. So if we multiply the second equation by negative 3, then equation number 2 becomes negative 15x minus 12y equals negative 81. Now we have equal and opposite. That's what we want. We need that first before we combine the two equations. So now 15x and a negative 15x together give you 0. Negative 30y and a negative 12y, that's a negative 42y. And a 60 plus a negative 81 is negative 21. And we can solve for y. Divide both sides by negative 42. Let's see, negative 42. And so we'll get y is equal to positive 1/2. 21 over 42. 42 is 2 times 21. And the negative signs cancel. We get 1 over 2, or 1/2. Now, in that problem, we focused on the x's to make equal and opposite. We could have just as easily focused on the y's and made them equal and opposite. So a 6 and a 4, well, the smallest number they both go into, or the least common multiple of 6 and 4, is 12. We can make both of those numbers into a 12 pretty easily. So if we multiply the first equation by 2, and we multiply the second equation by 3, well, 2 times negative 6 will be negative 12y. 3 times 4 will be positive 12y. And that's what we want. So if we take the first equation and multiply by 2, we'll get a 6x minus 12y is equal to 24. And if we multiply the second equation by 3, each term by 3, we'll get a 15x plus 12y is equal to 81. So now we've manipulated the two equations so that our y's, our terms containing the letter y, are equal and opposite. So now when we add these two equations together. Just like the 15x's canceled on the left, well, now the 12y's cancel on the right. So 6x plus 15x, that will give us 21x. And on the right, 24 plus 81 is 105. Okay, so to solve for x, we can divide both sides of the equation by 21. And we have x is equal to 105 divided by 21, or x is equal to 5. So our final answer is the ordered pair, 5 for the x, 1/2 for the y. So each of the 3 problems in this worksheet, you could have also used substitution, and the 4 problems on the previous worksheet where we used substitution, you could have used elimination. It comes down to a matter of personal preference. Again, I say I like elimination method, but that's just me. I didn't hit these special cases again where there's no solution or infinitely many solutions. Those I went through on my previous video, so I didn't feel necessary to go through them again this time. Okay, so that's it for this worksheet. I hope this was helpful.